Guys, welcome to YouTube channel Foundation JEE. Today's lecture is continuation of our previous two lectures, which was motion of an object along a straight line and motion with constant acceleration. In that lecture, we learned what does mean by distance, displacement, speed, average speed, velocity, average velocity, uniform and non-uniform motion, and also show the concept of acceleration and deceleration. Okay guys, now in today's lecture we will discuss motion of an object along a circular track where motion of the object will be uniform. Okay, and also we will solve one numerical problem based on circular motion for your better understanding. Okay, now here time to see the definition of uniform circular motion and various concept. Okay, uniform circular motion. Guys, here uniform stands for constant, okay, or fixed. Okay, so when an object is moving along a circular track with constant speed, then such type of motion is called uniform circular motion. Okay guys, in case of a circular motion, speed is constant, however velocity changes each point of the track. Okay, here track is circular. Okay, so guys, now see, suppose this one is a fixed point, say O, and particle or object is moving equidistance from this fixed point, then this track is known as a circle, or path is known as a circular path. Okay, now suppose the object is moving here with a speed of v, okay, along this circular track. Okay, now what you notice here, the direction of the motion of object is now like this one. Okay, so this direction of motion is, you can see, changes at every point. Okay, so that's why in definition we said velocity changes each point of the track. Okay, so direction of the object in this track is along tangent of the circle at that point. Okay, so you already know when a speed is constant and it has a direction, then it is known as a velocity. Okay, now, so guys, one question arises in your mind, sir, how could you say direction of the object when moving along a circular path is tangent of the circle at each point? Okay, so see the explanation here, guys. Suppose here this one is a square. Okay, now what's happened here? If you traces the direction of a speed, then in case of a square its direction changes 4 times. Okay, a square. Okay, now when it becomes the part of a hexagon. Okay, now what happen if speed is v, then in this case you can notice, guys, the speed direction changes 6 times. Okay, so when you increases the number of sides of the polygon, which is regular polygon, then in same proportionality the number of times the direction of motion of an object changes. Okay, so if you consider this one, okay, now suppose we draw here one regular octagon. Okay, so what you notice in this time, you see, okay, now this becomes the octagon. Okay, so you can see in this diagram the distance is now becomes narrow. Okay, once time come when you increases the number of sides of the polygon, regular polygon, then it becomes the part of the circle. Okay, see this small length. Okay, so direction at this time you can say like this one. Okay, so you can say, sir, when number of sides of the regular polygon increases too much, one time come the sides becomes the part of the circle. Okay, so you can say, sir, now direction of the object is along the side, or now it is becomes the tangent of the circle. Okay, so guys, hope why we say that at every instant of time the direction of motion of an object in case of circular motion is along tangent at that point of the circle. Okay, now consider this one case. Okay, so if you draw a circle here like this one, so what you notice here, distance is greater with respect to this distance. Okay, so when sides increases, so what you see, the side becomes the side of this circle. Okay, and particle is moving along the side of the polygon, so now it is moving along the tangent of the path. Now the whole path is circular path. Okay, so guys, next we see one numerical problem based on uniform circular motion for your more clarity. Okay, the question is, an athlete is moving along circular track with uniform motion, and he completes one round of the track in 88 seconds, and the radius of track is 70 meter. Okay, so here question is, find out its speed, and the second question is, find out distance and displacement at elapse of time 1 minute 50 second and 2 minute 12 second. Okay, so solution here, first information is given here, the time elapsed to complete one round equal to 88 second. Okay, now the radius of track which is circular is 70 meter. Okay, so you can know this path is circular, so we first here draw a circle here, see. Okay, now guys, suppose this is a center, or this radius is here 70 meter. Okay, so now what you know about the perimeter of circle? Okay, so perimeter will give you distance covered by the athlete in one round. Okay, so perimeter of circle, okay, equal to 2 pi, or this is r. Okay guys, so you know the value of pi equal to 22/7. Okay, so we can put the value here, and now you can see the radius is 70. Okay, so this is 1 or this is 10. Okay, so you can write it as a 440 meter. Okay, now you get here distance covered by athlete in one complete round, which is 440 meter. Okay, now so here speed equal to here distance covered by an object. Here object is, guys, athlete, or time taken, or you can say elapsed. Okay, so if we put the value here, so what you will get? You will get here, guys, this is 88, so 1, this is 5, 88 ja 440. Okay, so this is 5 meter per second. Okay, so now you can say, sir, speed of the athlete is 5 meter per second. Okay, now the second question is asking here, what will be its distance when time lapse is 1 minute 50 second. Okay, so see here solution of this one. So guys, here this one is a circle, okay, which radius is here 70 meter. Okay, now what information you get from the question here? Time equal to 1 minute or 50 second. Okay, so first of all we change the unit in second. Okay, so this is 60 second or this is 50 second. Okay, so you can say, sir, this one will be 110 second. Okay, or you can say, sir, this one 88 second plus 22 second. Okay, so what you get here, if the object or athlete is starting from point P, okay, then it takes 88 seconds to complete one round. Okay, then after elapse of 22 seconds the athlete will be here. Okay, because this is 1/4 time of one complete round. Okay, so you can say, sir, distance equal to speed into time. Okay, so now speed is here 5 meter per second into time elapse is 110 second. Okay, so this second cancel out, or you can say after elapse of 1 minute 50 second the distance covered by the athlete is 550 meter. Okay, then what about the displacement? Okay, so guys, you know, if this point is Q, then displacement only depend upon the shortest distance between the initial and final position of an object. It does not depend upon how the object reaches the final point. Okay, so you can say here it is independent of the path traveled by the object. Okay, so what is the shortest distance between point P to point Q is now this one. Okay, so you can know if this one is a radius, say r, or this is also radius r, then this angle is what, guys? Right angle. So if you get the hypotenuse or length of this right angle, then it will give you displacement of the athlete after elapse of 1 minute 50 seconds. So we can write here displacement in 1 minute 50 second equal to PQ, or PQ equal to here OP square plus OQ square, or take a under root. Okay, so this time you can write this is 70 square, or this is 70 square. Now you can also write here 70 whole square into 2. Okay, and you know we can take 70 out, or this is root 2. Okay, so finally you can say this value will come, sir, 98.98 meter. Okay, why? Because root 2 value is 1.414. Okay, so if you multiply 70 into 1.414, then the value will come this one. So we can say displacement of the athlete after elapse of time 1 minute 50 second is only 98.98 meter. Okay, so next question asking what is distance covered by the athlete in 2 minute 12 second. Okay, so in this case what will be the time in second? So time will be, guys, 2 minute here or 12 second. Okay, so we can write 2 into 60 second plus 12 second, or you can say, sir, this will come 120 second plus 12 second, so 132 second. Okay, so now you know the distance formula, speed into time. So distance covered by particle in time t equal to speed v into time. Okay, here v is what, guys? 5 meter per second, or this is 132 second. Okay, so you can get here 660 meter. Okay, now what about its displacement? Okay, so guys, you can notice here 132 second, if you subtract 88, then this is coming 44 second. Okay, then you can say, sir, it will only cover half distance of the complete track. Okay, so the particle position will be here. Okay, if this point is say M. Okay, so here to here shortest distance is what? You can say, sir, this one is a diameter of the circle. Okay, so as per definition here, displacement is a shortest distance between the initial and final position, which is here P or M. Okay, so this is 2 into R, or R value is, guys, what? 70. So you can say, sir, the athlete displacement after elapse of 2 minutes 12 seconds is only 140 meter. Okay, which is diameter of this circle. Okay, so guys, hope by seeing this numerical problem based on circular motion, the concept of uniform circular motion now clear to you. Okay, guys, if you think this lecture is informative for you and others, then kindly like, subscribe and share to your friends and family this YouTube channel, which is Foundation JEE channel. Okay guys, one more request from you. If you want to be updated for my next lecture, so please on your YouTube notification, because in next lecture we will discuss force and laws of motion. Okay, so thanks once again for listening and watching this lecture. Thank you.